This is Bob Capetta, and this lesson is on the complement rule. So let's remember we have an experiment. We're going to describe the sample space. So let's have our experiment be the following. Roll a die. The sample space is a set of all equally likely outcomes. So the sample space is the following set: 1, 2, 3, 4, 5, 6. We have 6 equally likely outcomes that can happen in this experiment. If E is our event, that we get either a 2 or a 3. The probability of E is the number of successes divided by the number of total. Again, if we have a sample space where all events are equally likely. So the number of winners, 2 or 3 out of 6, or if you like, 1/3. We want to describe something called E complement. This is the complement of E. Or if you like, not E. So E complement can also be expressed as not E. So the probability of E complement, the probability that E doesn't happen, probability of not E, is 1 minus the probability of E. So in this case, our probability of not E would be what? Would be 1 minus 2/6, which would be 4/6. But that shouldn't surprise us. We have 2 winners. 2 and 3 are our winners. These 2 outcomes make up E, so the other 4 are not E. So, I mean, there's our basic rule. Probability of E complement is 1 minus the probability of E. We can formalize these things. So let's go ahead and write them down. Probability of E complement is 1 minus the probability of E. Or equivalently with the other notation, probability that not E, probability E doesn't happen, is 1 minus the probability of E. But we can also switch it up, and we can say the probability of E is 1 minus the probability of E complement. Or if you like, the probability of not E is 1 minus the probability of E. So let's go ahead and take a look at another example. This time we are going to select a card from a deck. Select a card from a standard deck. Of 52. So our sample space will have 52 items in it. So it would start with what? The 1 of diamonds, the 1 of hearts, the 1 of spades, the 1 of clubs, the 2 of diamonds, the 2 of hearts, the 2 of spades, the 2 of clubs, ... You can see I really don't want to list all of them, but they're all equally likely. To be a sample space, all of our events must be equally likely. And let's say our event E this time is select a diamond. So if we're going to select a diamond, what will that be? We have to count the number of winners divided by the number of total. This is a sample space. All of these are equally likely. So the probability of selecting a diamond, probability of E, which is the same as the probability of selecting a diamond. How many winners do we have? Total of 13 diamonds, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King. 13 diamonds out of 52, which would be 1/4. So using our rule then, a probability of not E, probability of E complement, which is the same as the probability of not E, is 1 minus the probability of E, which is 1 minus 13 52s, which is 39 over 52. Again, 13 winners, 13 diamonds, 39 non-winners. And you can reduce that, of course, to 3/4. And let's take a look at one more example that gives us some data in a table. So let's create such a data set. We're going to take a look at students and grades. So this is one of my favorite examples. Let's take a look at various courses that students can take. So we can have math courses. So we could have Algebra 1 students. We can have geometry students. We can have Algebra 2 students. We can have pre-calculus students. We can have calculus students. So these are all of the math classes at a given high school. We will categorize people in these various courses based on the grades they get. And no surprise, as you move up in difficulty level, students actually tend to get better grades because they understand how, let's say, the high school game works. So we'll have A's first. A's, B's, C's, D's, and that's enough. We'll assume no one's going to get an F here. Let's go ahead and put some numbers in all of these columns. So let's say we have 2 A's, 8 B's, 4 C's, 3 D's, 5 A's, 10 B's, 6 C, 1 D, 4 A, 6, 9, 2, 10, 3, 4, 1, 16, 5, 2, 0. So these are all of the numbers that we have, and we want to ask some questions. For example, we'll have E be the event that a randomly selected student is an algebra student. A randomly selected student is studying algebra. So to do that, we have to figure out how many algebra students do we have and how many students do we have altogether. 10, 14, we have 17 algebra students. Then we have 15, 21, 22 geometry students. 10, 19, 21 algebra 2 students. So I'll say algebra 1, just to clarify that. 13, 17, 18 pre-calculus students. 21, 22, 23 calculus students. So how many students is that total? So our event is randomly selecting an Algebra 1 student. So if we add all those numbers up, 17 plus 22 plus 21 plus 18 plus 23, we get 101. 1, 2, 3, 4. Okay, 101 students total. So the probability that the person is going to be an algebra student will be your Algebra 1 student. E, a randomly selected student is studying Algebra 1. So the probability of E then would be how many winners total? 17 divided by 101, which we can get a decimal approximation for that. 17 divided by 101, about 0.1683. So the probability a student is not an Algebra 1 student. So we'll use a not notation this time. Probability of not E. Okay, so using our complement rule, the probability that you're not in group E will be 1 minus the probability of E, which is 1 minus 17 over 101. So what is that going to be? I believe that's 84 out of 101. So there's 84 other students in our group here who are not studying Algebra 1. What is 84 out of 101? That's a decimal point 8317 in 4 decimal places. So, I mean, that's our basic idea. We have 2 rules. Let's just quickly remind ourselves of our notation. So we have a sample space which is a set of all equally likely outcomes. You have an event, which is some subset of the sample space, some subcollection of items from a sample space. Then we can have a complement of an event. And the complement of an event is the event does not happen. So our probability of E complement is 1 minus the probability of E. Or if you prefer the other notation, the probability of not E is 1 minus the probability of E. Similarly, the probability of E is 1 minus the probability of E complement. Probability of E is 1 minus the probability of not E. So those are the basic ideas we have for the complement rule.